All right. Perfect. All right. It's noon. We're going to get started. Thank you all for coming. We're really excited to host this panel on AI innovation in the recycled materials industry. My name is Hougo. I'm one of the co-founders of ReMatter. We're a scrap software company that services the metal recycling industry. We have a all-star panel of folks who are deploying really interesting technologies, software, hardware, you name it, throughout the industry. And really, the reason why we put this panel together is to just showcase some of these technologies, talk about, market trends that we're seeing, and at the end of the day, how these can impact your business. So before we jump into the slides, would love for everyone to introduce themselves, you share a little bit about you and your company.
Yeah, so I'm Julian. I'm at Redwave. So we're an Austrian-based company, and we are producers of sensor-based sorting machineries. And yeah, for the metal application, we have our sorting technology of XRF, which I'm going to tackle a little bit in later. Yeah, so as said, we are based in Austria, and we have a little subsidiary in the US, in Alpharetta, Georgia. Yeah.
Good afternoon, everyone. Atilla Widnell from Navigate Commodities, based in Singapore. Navigate uses geospatial data to monitor global flows of bulk commodities, and also a subset of that is sort of shortwave infrared thermal satellites to monitor sort of smelting activity across steel, copper, alloy, nickel in real time. And basically give insight in terms of price risk, mitigation, hedging, and stuff like that. So we'll talk more about the mechanics of that and how we do it and how it can be applied to supply and demand.
Raghav, Mecheri, CEO at Visia. We build AI-powered non-conformance detection systems for large-scale recycling businesses. So our claim to fame is we can find lithium batteries, propane tanks, acetylene tanks, toner cartridges, unwanted materials within your inbound material coming into the yard.
Awesome. Super appreciate it. So yeah, rockstar panel here. Excited to dive into it. Sorry, those I had the clicker here. Okay. All right, cool. We already met the panel, talking about everyone. So why are we here? So AI is one component about what we're talking about. Obviously, wanted to provide a little bit of context and color on it. If you watch the news, you see it everywhere. But wanted to take a step back and, really understand what are the business applications of AI. And I think there's sort of like three key pillars of it. One, the way that we work as individuals, as companies, is radically going to change over the next 5 to 10 years. We often talk about automation, coming for jobs, and sort of the side of labor is potentially going to get replaced. But at the end of the day, just like any software system, AI hopefully will allow us to do our job more efficiently, regardless of what part of the business we're in. The second piece of it, and I think we'll chat about it now, is you can start making business moves right now and those upfront investments to set yourself up from a platform perspective as it continues to advance. And ultimately, we want to use this technology to drive better business decisions and margins for operators. So just a quick raise of hands, how many people use ChatGPT on a weekly basis? Okay, that's pretty good. How many people have heard of Microsoft Copilot or use it? Okay, all right, cool. We did a panel like this last year and only like half the room raised a hand. So it seems like over the past year, a lot more engagement with these tools. AI, we see it in things like sports, right? If you go to the baseball game, Petco Park, AWS, Amazon Web Services, they give you all the metrics and stats. NFL, same deal. We see it in entertainment, but again, tie it back. Where's the business value? So underpinning artificial intelligence and, ChatGPT, things like that are, what are called large language models. These are essentially computer models that can process lots and lots of data. Part of why AI has been able to advance so much is these LLMs are able to support what are called context windows, which is essentially just data that's, that you can feed into the system. So because we can fit larger and larger context windows, they can do more computationally heavy work. And a lot of the technologies that these guys use will continue to get better as the underlying LLMs improve as well. So what we've seen is a series of valleys and peaks of AI. And obviously, we're at a global maximum of this technology. Basically, we needed enough computational power to support this tech. So if you've invested in NVIDIA, you're probably very happy with your stock price over the past couple of years. They're making the processors that have enabled a lot of these tech companies to continue to propel it forward. The other huge tailwind to all of this is private investment in technology companies that are doing stuff in AI. Obviously, 2021, huge outlier in terms of the amount of capital that was going into companies. But even if you look at the venture landscape, private equity landscape, so many companies are focused on AI. So we'll see it play out in consumer and business products over the next couple of years, especially with how many companies are focused on it. We've already chatted a little bit about the consumer products, and then talking through a little bit more. Data is going to be the key piece to you being able to unlock business value. And what I mean by that is having data in a system of record that a ChatGPT, OpenAI model can work and deal with, and their platforms will talk a little bit more about that. So what can AI do for me in the scrap industry? That's ultimately why we're here. In a world with AI, we're able to go from manual data capture to automated data capture. We're able to identify materials that otherwise we need someone to do on their own, and take complex business back office processes like scanning and documents and stuff and ingest them into a system that can utilize them. So wanted to go through two just real quick demos here. One is on computer vision. So throughout the industry, we often hear it's very hard to train operators on identifying materials, right? It's a high turnover job. You need to, there's so many different grades of material, and computer vision could be a big unlock on that. So one of the quick demonstrations we wanted to show is, imagine you put electric motors onto a scale here. With enough data and photos, you could say, hey, we think with, this % confidence that this is an electric motor, and identify anomalies between what an operator said is on the scale versus what the computer model thinks. And none of this is foolproof, right? But the idea is to flag potential misgrades from the operators. So wanted to show another, quick example of this from a mobile perspective. So the way that this is work is you can imagine you have a buyer who's, out on the yard. They're able to snap a picture. What we're essentially doing is ingesting a photo against a large language model that's trained on all these different images, and then we're able to classify what that material is. So again, this is a very simple demonstration, but just trying to showcase, where the technology is headed in the industry. The second is data exploration. So this is more on sort of like the ChatGPT side. You drop in an Excel file, ask it a question. If you have a right system of record, you can basically just give it what are called natural language prompts, and then it will generate some sort of graph or visualization for you. So for the second demonstration, wanted to roll through. This is something that we toyed around with ReMatter. Essentially, what you're looking at right now is, imagine you have all your data in one spot and you want the system to generate a chart, right? Previously, you would have to pay someone who to go in, they know an Excel file. Here I'm saying create a bar chart with my purchase volume by facility. The system thinks through it, and then it will generate the image on top of it. And all the system is really doing here is writing the underlying code and providing the visualization. So again, this is a very simple demo, but just wanted to showcase some of the new technologies that are going on here. Okay, charging ahead. Obviously, I'm going to be moderating this panel, but wanted to turn it over to Julian to share a little bit about Redwave and what they're doing in the space.
Yeah, so as said, we are producers of sensor-based sorting machines, and I want to talk a little bit about AI in sorting machines. So what first of all comes into mind is looking at the belt, seeing, okay, this is an aluminum can, this is a PET bottle and stuff like that. But I want to tackle a little different area. For that, I need to go back a little bit. So in metal sorting, as I said, we are using the technology of XRF, which stands for X-ray fluorescence. And just a very high level, how that works is we are shooting with an X-ray beam on a piece. This gives us back some energy. We are measuring this energy, and this is individual for each element in the periodic table. And so we can identify different types of non-ferrous metals. So what we get from this signal is some kind of a graph where it has some peaks in certain areas, which allow us to separate different types of metals. So as what you can see here is now what we did in the past basically is we looked at certain areas in the spectrum and saw here in this area there's a big peak which we know at this energy level stands for copper. So it's pretty easy to identify copper. But it has some limitations. So the lighter an element is, the less energy we get back, and the height of the peak gets lower. So for heavy metals, this works perfect, and we do not need to do anything else here. But as we go down to aluminum sorting, these are very light elements, and talking about alloying elements such as magnesium and silicon, we cannot do very much with just looking at single peaks at a spectrum. So for this is an example. The red line here is an aluminum piece. The blue line here is a brass piece. So the differentiation is pretty easily and can be done very easy. So with this technology, we can tackle 10% of the non-ferrous metal mix, but 85% of the non-ferrous metal mix is aluminum. So we needed to find a solution for aluminum sorting. And this is where we come to, we call it spectral analysis. So here you can see two different aluminum pieces compared to each other. One is a cast aluminum piece and one is a wrought aluminum piece. And here you can see there's not much of a difference between those two pieces. But what we saw is that not looking at single pieces, but comparing the whole spectrum to each other, we can see some differentiation in certain areas. And this is a part where we will use AI to basically make drop tests, drop down 200, 300, 400 pieces of the same alloy. And then we have a model or a data bank in the background where we can then compare the spectrum to another piece and so identify, okay, this is a piece of 5000 series aluminum, this is a cast piece, this is a wrought aluminum, and yeah. Jump over that. This is another way where we implement AI in our sorting machines. So what you can see here is two overlapping pieces, and this is with sorting, it's always very difficult to have two overlapping pieces because the right image you can see here is what our system sees. Our system thinks this is one big piece, and if we just see one big piece, then it's difficult to separate the two pieces from each other. So we are in this instance we have one clear glass piece, and the black one is basically a heated glass piece. So we need to decide, as we can just see it as one big piece, do we shoot on it or not? With AI, we now recognize, because visually you can see there's two different pieces, and we are using this with AI to recognize, okay, there is different, these are two different pieces, and I can eject this one piece separately, and this other piece doesn't need to be ejected. So we can split them up, basically, what we couldn't do before. This allows us to go a little bit higher in throughput, because we can afford some overlapping at certain areas, and also allows us to have more higher efficiency and purity rates at the end. Yeah, this is just some demo material from our side.
Awesome. Thank you.
Perfect. So you're gonna have to bear with me. The jet lag is kicking my ass a bit, but yeah, I'm trying to hold it together. I definitely wasn't out drinking last night either. But so yes, we're here today to talk to you about sort of geospatial aspects, the market. And I hate using the word market intelligence, but geospatial intelligence sounds a bit pretentious. So what we really do at Navigate is using high frequency satellite data, images, and so on to uncover high frequency sort of monitoring of supply and demand all through the value chain. Just a quick disclaimer. We won't worry about it too much. The main point of the technology, what we're doing is to create that end-to-end supply chain visibility. So we're tracking everything from, say, the mine or the yard all the way to the smelter, and so we can see, you know, what's being loaded where, how often, what's sitting on the water, where's it going, where's it getting discharged, and how hot is the smelter operating at. And all that data fed sort of back to the end user via APIs or WhatsApp or a web portal and so on, So there remain two main sort of verticals to our portfolio at the moment. One is looking on the sort of maritime side. So if anyone's ever used marine traffic, we're kind of like the marine traffic for commodities on the dry bulk. And then we have the earth side with a very mature product in terms of using shortwave infrared thermal satellites to monitor the heat emanating from the blast furnaces, the electric arc furnaces, the coke ovens, slag beds, and so on. That's really our sort of foray into AI computer vision, which Drake was sort of touching upon. The rest of it sort of more rules-based ML algorithms and so on. So I don't want to oversell what we do. A lot of it does come down to logic, but I think hopefully we just about make the benchmark for innovation. So what we're currently doing at the moment is tracking on the maritime side all of the flows globally for ferrous scrap, pig iron, HBI, iron ore. We've just ventured into nickel pig iron, nickel ore. So if anyone's got exposure to stainless or nickel, we're actually on another panel after this one, talking about sort of the trends that we're seeing in those markets. The main point about the maritime data, as I was sort of touching upon, was that we can see everything that is being loaded in real time. We sort of set a frequency of about every 4 hours, so we can see short sea, deep sea, tranship, ocean going barges. The missing piece of the puzzle for us at the moment is looking at river barges. We are doing it in North America. We are doing it in Northern Europe already because they're motorized barges, so they're a lot easier to track. But we're actually currently working on the Mississippi barge flows at the moment for ferrous scrap and stainless scrap. So in terms of the value prop, it's being able to see that high frequency S&D every 4 hours. So if you're a scrappy, who your competitors are selling to and who your buyers are buying from, and so on. And if you're a mill, who your vendors are supplying to, and who your competitors are buying from. So this is just like a sort of holistic picture of the platform. So at the moment, you can see sort of all the short sea, deep sea tranship vessels on the water currently laden with scrap. And you can interrogate each individual vessel, and so you can see where she's come from, where she's going to. So this is HKS, which is TSR Recycling. The vessel the specific reason I chose this vessel is because it's crossing the Atlantic, going over to Nucor with a deep sea cargo. And as we know from the market side of things, Nucor typically only buying sort of PNS, busheling, high grade quality scrap. So we have an idea about what type of scrap she's sort of currently laden with. And so you're tracking all those flows globally. And this is the point about the barges. I mean, at the moment, we've rolled this out to North America. So we're tracking all the ocean-going barges down the East Coast, so we can see what the supplier profile looks like as well. So we can see that, over the past 12 months, the majority of the suppliers that have sold into Nucor, Hartford County ports, Sims, EMR, unsurprisingly, really. So the next iteration will be tracking those flows up and down the Mississippi, and pardon my poor geography, I think there's the Arkansas River and the Ohio River, I think, as well. So we'll track those flows as well as they branch off. So, we're learning about the US markets, and so we're understanding about, everything that happens with those tugs and those tows and the staging areas, and how, barges are sort of added to it and taken away from it, and so on. So a lot of this technology comes down to, if you have a solid methodology, you then can apply it with algorithms and AI and so on, and then roll it out sort of globally. But it's quite fascinating. Every little market has its own intricacies and nuances. So, how we built the North American East Coast ocean barge coverage was actually informed by our work that we did with nickel ore in Indonesia, because you have one tug, one ocean-going barge from legal and illegal mines across Indonesia, and we're actually the only company in the world that's tracking nickel ore sort of flows or production in Indonesia in real time. And that data correlates 1-for-1 with government statistics, which is just phenomenal when you think about sort of the frequency of those sort of flows and those coverage. The second vertical that we built and that we're actually running with the Singapore government is the Earth vertical. So as I said, shortwave infrared satellite images. It's just a funky name for thermal images, where we detect the invisible spectral bands emanating from those plants. And obviously the value prop is being able to see, more than 917 smelters all across the world, on a daily basis. How much are they producing? You can make inferences about how much scrap they're consuming, how much iron ore they're consuming. We can see coke ovens, EAFs, blast furnaces, DRI modules. I probably should, caveats that, technology is very robust and it works very, very well for sort of integrated steel making plants, because they operate on a quite consistent level. So we do have a metallurgical background as well, so we understand the mechanics of it. On the EAF side, it's a little less accurate. So like on blast furnace side, it's like 95% level of accuracy. On the EAF, it does drop quite considerably to about sort of 70, 80%. Why is that? Generally speaking, because obviously you have sort of anywhere between like sort of 2-3 different shift patterns throughout the day. Your tap to touch times are shorter, 45 minutes to an hour and a half, depending on the plant. And so if you're only having a daily revisit, you're not necessarily going to catch all of those changes across the day. So there are sort of drawbacks with the hardware upstream, but it does give you a very sort of holistic view of what's happening all around the world, and having, not to completely rely on agents, completely rely on, sort of news, by the time you may have read about it in fast markets or, I don't know what the other one, Davis Index or not picking on anyone, but, it's usually too late. Whereas, you can see binary on off, production levels and so on, and get a good idea, are any of your, sort of clients, suppliers, vendors, so on or off? Are they struggling with any production problems and stuff like that? So this is just to give you an idea about the mechanics. These are what the images look like. So we're not actually taking pictures of plants. It's a very sort of it's very much a thermal image where you can just see the hot spots, the invisible spectral bands. So it's not like we're taking a picture of you in your front room and sort of spying on you. It's very sort of, it's more sort of a heat sort of signature rather than anything else. So we have different spectral band images that are sort of meshed together. We use different constellations, which is a fancy word for different sets of satellites, and then we mesh all those together to create a high frequency sort of coverage. So I'm just picking on ArcelorMittal in Fos-sur-Mer as an example. And then what we do is we segment the site. So this is where the metallurgical aspect comes in. So I think maybe this is a good point to talk about just how sort of technology and, real industry subject matter expertise comes in together, because it's not just about being a techie coming into commodities, because we've noticed that's where a lot of products tend to fail. You need to have that subject matter expertise as well as blending it with the tech together. So being able to know where the blast furnaces are, the sinter plants, coke ovens, because no two sites are the same. The boss plants, where are the torpedoes coming from? Where are they going to? So should you assign the heat signature from the torpedo to the blast furnace or to the boss? And all those kind of things. And also, knowing where the slag beds are, and then being able to say, okay, well, if there's heat emanating from the slag beds, then it must be coming from the blast furnace and so on. How to discount gas flares, because the hot gas can be coming from the blast furnace. It could also be coming from the coke ovens. I told you I was going to rant a bit, but yeah.
What's the typical refresh rate on the satellite imagery?
So at best, 4 to 5 times a week.
Okay.
So we're using NASA and European Space Agency constellations. So if you don't like being spied on, you can blame NASA. Don't blame me. And it is, surprisingly, it is all public information. The magic is in the source. So it is a secret source of how to apply computer vision techniques to being able to detect those hot spots, and how to, sort of look at the pixels, how hot is it sort of burning compared to, the last sort of 9 years. So we have 9 years worth of historical data. And so that's just an aggregation of all the hotspots you can see. And so therefore you can see, generally the activity of each particular plant. And so then when you put it into a front end, you can see, okay, well, the coke ovens are off. We know that about Fos-sur-Mer. We know that blast furnace 5 or whatever it is, 6 is off, but, there's heat being produced by the other blast furnace. Boss plants are hot and so on. So you then start to pull in that inference. So if you're selling coking coal, or you're selling scrap, or you're selling iron ore to a particular plant, then you have a good idea that you don't need to necessarily trust what your client is telling you. So if you're obviously selling into EAFs as well, the same logic applies on scrap. And then when you think about it, actually, the power of this technology is not just plant by plant, is actually in as a whole. So, if you're exposed to the seaborne market for scrap, it's knowing exactly what's happening in Turkey, for example, because you've got 27 EAFs in Turkey. So knowing who's on, who's off, how much they're producing. If you're selling iron ore, or buying iron ore, you need to know what's happening in China. This is not something that we tend to advertise too much, because being in Singapore, I'm right on their doorstep, so I don't want to be black bagged and disappear. But generally speaking, knowing what sort of 200-300 blast furnaces are doing in China then gives you excellent proxy in terms of what's happening with the hot metal production, and therefore how that's going to impact the iron ore price, because that has such massive ramifications for the whole of the ferrous industry as well. So when you start to think about it globally, it then leads into price risk mitigation, hedging, so on. And so, we work with SGX, we work with LME as well. And so we feed sort of intelligence into them and how it affects their markets too. We write research reports. So you can see at the moment there's 917 active smelters all across the world. The beauty of this technology is once you've built the methodology and the tech stack, it can then be applied to copper, aluminum, nickel, and actually we're going over to Charleston on Monday, see if we can uncover the methodology or logic for applying it to graphite electrodes as well. So there's just so much you could do with it. So once you've got it working. And then the third vertical, which I didn't talk about, and it's a bonus slide, and just to freak you out before we finish, hopefully this plays. So this is optical imagery. So this is proper spying. That's a shame. So the optical imagery that we use for this, you can't see it, but we're basically monitoring stockpiles of scrap, and it can be applied to scrap, iron ore, coal, and so on. So we no, okay, no worries. And so we're able to detect the grade of the pile, the size of the pile, and so on, the mass. And so now that we're doing, the methodology's been built, the MVP's been built, it's just damn expensive to run. So we need some volunteers from the audience to subscribe to that afterwards, so we can fund that project. Yeah, I mean, the main point being is that, not just looking at a particular yard, again, because there's no real value in that, but when you're looking at a country as a whole, and you can see, as a country, UK, US, is country overstocked or understocked with regards to stockpiles and inventory? And how does that play again into the price risk? So then when you piece all of these pieces of kit together, you've then got, we're monitoring what's sitting at the dock, what's being loaded onto the vessel, what's sat in the water, what's discharging at the disport, and then what are the smelters operating at. And then, I'm not going to take any credit for this. It's just by accident that we built all of those pieces of kit together. I'd love to say it was a stroke of genius, but it was just by accident. But then you have a digital twin of the supply chain, and that's incredibly powerful in terms of being able to monitor all those different types of commodities. And so these are some of our valued clients that we're working with. Commodity trade, big commodity traders, sort of exchanges, steel producers, scrap suppliers, ferrous and stainless scrap, all over the world. So we're very, very fortunate to work with companies of these size. And so, they're all sort of quite visionary, I would say, in terms of adopting technology. And yeah, that's really us.
Yeah.
But thank you very much.
Which button is it?
The
One. It feels like I always get stuck with the slot before lunch. So I apologize for being in your way. I will try and keep this short and sweet. My name is Raghav. I am the CEO here at Visia, and we build AI-powered material analysis systems for non-conformance detection of material coming into facilities. So we've been around for give or take 3 years at this point, have had the good fortune of servicing folks across the supply chain. Our big belief is that material intelligence, specifically inbound material intelligence, will transform the way we look at recycling as a whole. If you think about recycling slightly more tactically, it's effectively manufacturing in reverse, right? And just like how for a manufacturing facility, end product quality control is the most important aspect, it's our belief that for recyclers, inbound product quality control is the most important aspect. Because if you can guarantee consistency in the material that comes into your plant, I know that sort of sounds impossible, but if you can guarantee some level of consistency, you see impact in your downstream operation sort of across the board. So our belief is that the biggest problem is that inbound material itself is unpredictable. Show of hands, how many folks have seen a lithium-ion battery fire? For those of you whose hands are down, I envy you, and hopefully you never see one. I saw my first one in 2021, and it was probably one of the most terrifying things I've ever seen. The fact that you have to shred material to put it out is just mind-boggling. Anyway, that's just one example of what happens when we don't have enough visibility into the materials that come into our MRFs, e-scrap facilities, yards, waste energy sites, whatever it may be, right? But these problems extend beyond just non-conforming items causing safety issues. You often have issues with procurement, right? You hear people making jokes about, oh, I bought a load of 40,000 pounds of ferrous. Was it actually 40,000 pounds of ferrous? Or was it 30,000 pounds of ferrous and 10,000 pounds of organics? Often we don't know until it's too late, right? And then you look at material auditing, you look at compliance regulations, you look at everything else that sort of requires you to know what's coming into the facility. And that effort really does add up. And so our belief as a business is that recyclers truly need visibility into their inbound material streams. That's what we do. We co-develop, build, and install a combination of cameras, conveyor belt x-rays, full scanning cargo x-rays for trucks, and on occasion CT scanners, but that's really a story for another day. And we actually build these systems with artificial intelligence from the ground up. So we build autonomous analyzers of material coming into plants to A, understand the overall composition coming into the facility, and B, to alert on instances of non-conformance. So I have a couple of examples here for you. One of them is cameras detecting black bags on tipping floors, whether it's a MRF, a yard, a waste energy site, or something else, detecting visual contamination as it comes in, understanding what the material stream is, finding the bad stuff, and prompting operators on site via mobile app or via some kind of alert to say, hey, person XYZ dropped off XYZ material. Turns out 30% of it is not what they said it was, right? Another example of this is detecting lithium-ion batteries through burden depth. So think of it as a battery underneath a bunch of, ferrous metal on a conveyor line as it moves through a plant. Now, when we do these systems on conveyor lines, which is not the only place we do them, but when we do them on conveyor lines, we typically pair them with a laser pointer. So think of it as, I'm standing on a conveyor, either triaging or quality controlling material. All my material goes through the x-ray, and then stuff that's bad or stuff that's hazardous, which, we work with each site to sort of confirm, a laser dot sort of points at it and tracks it on the belt, actually facilitating removal of these items. So we have these systems at a ton of municipal recycling and e-waste facilities across the country, and they pull over 150 batteries a day, which is a stunning number, at least for me.
And quick question. What are the biggest differences in deployment between waste facilities and MRFs and metal recycling? Obviously, the material composition is pretty different.
So there's probably two big differences. I would say the biggest one is the kind of hardware we use. So we, as a business, what makes us I think the word unique is a little bit overused, frankly, but I think what makes us distinctive is we have the ability to support hardware across different kinds of settings. So to me, a camera system on a yard floor is the same as a conveyor x-ray leading up to a shredder, which is the same as a truck x-ray before your scale. And so the big differentiator is really what kind of hardware we install, because at the end of the day, you want to build technology that integrates into the facility's operations and not the other way around, right? So almost coming in with different kinds of hardware lets you build your own boat in some sense. The other part, like you said, is material stream, right? Like a municipal recycling facility will have a very different inbound stream to, say, a yard. That's another place where we do things a little bit differently. So because we custom build AI models for each individual piece of equipment at the site, we embrace the difference in material instead of fighting it, right? So you talk about seasonality, you talk about different regions having different kinds of material. Building one, mother of all system to power every single cargo scanner we deploy is just not feasible. We can't do it at the accuracy rates that we need to deliver to actually detect hazardous items and to be useful while simultaneously supporting everything in one way.
Mm-hmm.
So what we do is we build custom units for each site and really train almost what I call mini models per site to actually deploy them and drive the accuracy rates we drive.
Yeah, definitely. And one more question too. A camera is only as good as the stuff it can see. So what are the differences in sort of performance between like camera and X-ray?
The difference is physics, right? So like you said, a camera can see what it can see and X-ray can see what it can see. Our accuracy rates are pretty consistent across cameras, X-rays, cargo X-rays, et cetera, et cetera. What does change is what each kind of sensor unlocks for customers, right? So if somebody told me, hey, I want to scan an entire truckload of, ferrous material coming into a yard, and I only will use a camera, I will very politely and respectfully say it's not humanly possible because a camera cannot see through stuff, right? So the limitation is more physics than it is performance. It's our job to make every system perform the same, irrespective of what imaging system we use.
Awesome.
So this is a slightly more mainstream example, which is black belt detection with a camera, right? So this is another fairly popular request, which I would say is on the simpler end of the spectrum, which is just how much of my belt is empty and how much of my belt is over full, and how can I use that to sort of meter my operations, whether that's, change the speed at which I'm actually loading the crane before the shredder, or whether that's, change my shaker table configuration to actually make sure the materials won't spread out so that, the eddy currents and the other sorting systems that folks like Julian make way better than we do can actually perform the way they should be performing in these situations. Another example is detecting changes in metal composition within conveyor lines through burden depth. So the fun part about a lot of what we do is we don't care if there's stuff underneath other stuff or stuff on top of other stuff. We just blitz through it all the same, which makes life pretty fun. And so this is detecting changes in non-ferrous material on a ferrous stream, right? So think of like after an auto shredder, if you have a conveyor full of ferrous metal, but if there's more copper on that line than there should be because, it's not really going over that whatever jump that you have to separate ferrous and non-ferrous correctly, we are able to put in these very lightweight X-ray systems on conveyor lines to automatically detect when that breakup or when that divergence occurs and notify the site manager, notify somebody else on the plant to actually, tweak something or a part of the system. This is probably our most fun project. These are 20 by 60 foot cargo scanners that go in the front of operations at the scale. We typically use these systems to detect contamination. So what I call hazardous contamination, lithium batteries, propane tanks, acetylene tanks, nitrous oxide tanks, lead acid batteries, alkaline batteries, the list can, unshreddables, the list can sort of go on, but stuff that's coming in that's going to disrupt operations, hurt people, cause risk is typically the biggest thing that we pull out of these systems. The other thing we do is overall composition analyses of every load coming through the scale. So going back to the previous comment I made about is 40,000 pounds of ferrous actually 40,000 pounds of ferrous, or is it something else, is typically a question we are very effective at answering, all the way down to weight data. So we give folks breakdowns, and for example, this much ferrous, this much non-ferrous, this much aluminum, this much copper, this much dirt, this much organics. And a lot of the time that actually helps folks at the scale right size maybe what they should be buying when they actually, commit to procuring that load as it comes through. And again, the way we drive change at these facilities is highly customizable. So we do everything from pointing lasers on conveyor belts to, notifications via mobile apps, to putting up television screens at different points of the facility that sort of go crazy. We have a couple of customers where we just literally hook up alarms to like audio and make it blare. And so really the way we drive change on site is single-handedly determined by the facility operator what the team's operational constraints are and really what the folks on site believe to be the most impactful. What we really bring to the table is the ability to analyze the material stream irrespective of where it is, irrespective of what it is, and irrespective of, sort of what the variability of the material might be. I describe us as a well-kept secret because until like 3 months ago, we basically had zero marketing budget. So those that have seen me or heard of me have probably seen me in situations like this before, maybe without the knee brace and maybe pacing around instead of sitting down, which is typically what I end up doing. But in this case, I'm sort of stuck here. But we've had the good fortune of servicing close to 30 recyclers in the last 3 years we've been in the market. We are actually pan supply chain. and pan-end market. So we work with folks in the municipal recycling space, the e-waste space, the battery recycling space, the waste energy space, the recycled metal space, and the list goes on. One thing I make an effort to point out to people is this is probably our single biggest strength. And the reason is one man's feedstock is another man's contamination, as I joke. And so because, for example, we work with folks in the battery detection space or the battery sorting space, one point that everybody else in this panel has made is the value of data, right? I see, well, not me, the machine learning system, sees like tens of thousands of batteries coming into battery recyclers. So then when we see, one in every hour at a municipal recycling facility or, a couple every hour at a recycled metals yard, we know what they are because we see them in volumes that just otherwise our other customers would not see them in. So by existing across the supply chain, we're actually able to leverage training data from multiple settings and use it to benefit all our customers across the board, because the stuff that you don't want coming into your facility is probably stuff somebody else really wants coming into their facility. Mm-hmm. And if you learn to play that trade-off, you can actually build really efficient data sets. The big piece I sort of nail in on when I talk about what we do is we actually audit our systems in the field. So the big lesson we've learned through, I think, building, what I would describe as cutting-edge AI systems for the recycling industry over the last 3 years is it has to be what you say is what you get. And with artificial intelligence, what you say is what you get is probably the hardest thing to do, because unlike traditional software, you don't actually know what the systems are going to do until they're on site doing stuff at the facility, right? And so we solve this problem the old-fashioned way. We take duffel bags filled with lithium batteries, propane tanks, and all the other bad things we want to detect, take them to each facility, drop them on one end, make sure they get picked up on the other end, and all the accuracy numbers we actually state are not accuracy numbers from lab experiments and not accuracy numbers from, something I did on my computer. They're accuracy numbers from me having dropped 100 batteries on one end and seen 96 get picked up on the other end and gone, okay, cool, 96% accuracy. And we don't just do this once, we do this every quarter with every customer we have. The logic being that, composition analysis on conveyor belts is one thing, business data is another thing. But when we're preventing thermal events and when we're trying to keep people safe, the margin for error is really, really small. And 94% accuracy still means you miss 6% of batteries. I think everybody in this room would agree that if you take 100 batteries and you still put 6 of them through an auto shredder, it's still bad. And so, while we mitigate risk to our best possible ability, the logic of actually auditing these systems in the field and, going on site and doing it with the customer is it also lets us build a very good sense of understanding of what these systems actually do and allows our customers to build their processes around that, right? Because if you sort of work with someone to say 95 is still better than anything anybody else has seen, but it's still 5% less. So let's, put human-driven QC processes, or let's run material twice, or let's do whatever else we have to do to make sure we mitigate your risk in the way that we need to, ends up being a pretty powerful driver as well.
So, yeah, just a clarifying question too, because just really want to double click on, the lithium ion point. You go to any of the safety seminars that ReMA's putting on, and this is a hot topic. Anyone who's, seen these fires, they're pretty gnarly to put out. So does the technology, going back to the cargo X-ray scanner, so you could have a dump trailer coming in with, multiple cars and stuff. And let's say like a bird scooter, lithium ion battery is in the mix. Are you able to detect anomalies at that scale, or?
Yep. I could tell you where in the trailer it is. I could tell you what chemistry the battery is. I could tell you how big the battery is. And then I would probably work with someone at the plant to figure out what to do based on those things. Mm-hmm. So for example, we have some customers that will say, if it's alkaline, let it ride. Because at the end of the day, we can't stop every trailer. Some customers will say, I don't care what it is. If it's even the tiniest thing, I want to be alerted. And so there's where the customization comes in as well, to sort of work with folks to see what's relevant and what isn't. But yes, that is almost entirely in our wheelhouse.
Yeah, that's awesome.
So going back to the point we made earlier, we custom build implementations for every facility. And people might look at this and go, this is a weakness. I look at this and go, this is a strength. Because again, no two recycling operations are unique. And no two recycling operations are the same. Every recycling operation is unique, was what I was trying to say. And as a result, the only way to make things work well is to fit it into the uniqueness of that facility, right? And it's really hard to know what that is until you're there, boots on the ground is a little bit hard to do right now, but typically boots on the ground, and then actually understand what the process is on site. So we work very closely with on-site teams to design implementations of the platform, right? So we have all these building blocks. We have conveyor x-rays, we have truck x-rays, we have cameras, obviously all come with their own requisite, CapEx and operational costs, right? So what is the problem we're trying to solve? What tools do we have at our disposal based on the budget to solve them? And then how do we put those tools together to build a solution that's actually well structured for your plant? Ends up being something we spend a lot of time on. And then finally, validating and measuring not just business impact, but actually AI performance of the system is the second big piece. Because again, 94%, 95%, 96%, I could keep making numbers up. It doesn't really mean anything unless 96% of the batteries actually leave, the trailer, or actually leave the conveyor belt, or actually leave wherever they are to begin with, right? And we do really, really, I would say sometimes stressful, but really, really involved ground level ongoing support. Because the other parts is that, like everybody else has talked about, we are in the very, very early innings of this technology. We've been around for 3 years. And while we have been, I think, flattered by the, rapid maybe applications we have seen in the last 3 years, at the end of the day, we've only been around for 3 years. And there is a ton of things that we work through at almost every site with almost every customer, especially when the downside of missing lithium batteries is as high as they are. And so our solution is we show up. People call us and we just appear. And if we don't appear, we're not doing our jobs. Ideally, we appear within 72 hours. If you're not close to a major airport, you might need to give me another day or two, depending on where you're at. But we try and come by as fast as we possibly can, and we try and fix these issues on site. So we've had situations where customers will call us and say, hey, I've started getting this new type of battery, or like, especially in e-scrap, for example, where, the material stream is so diverse and almost everything is electronics and they're shredding it, right? They'll call us and say, hey, I got this new kind of battery the other day. And we're like, okay, can you put 10 of them aside? We will swing by at some point in the next week. We will run those 10 or 20 through the system 100, 200, 300 times, teach the actual machine learning algorithm how to identify them, and then show you that we're doing it before we leave. And that's sort of the value of these systems, is once we know what we're looking for, that data set keeps growing, the application set keeps expanding, and we almost always keep adding new things to look out for as well.
Yeah, and that's one thing I wanted to double click on, because Atilla, I think you mentioned it too. You guys have 9 years of data that you've been able to train on. I'm curious for both your guys' perspective, like at what point, what size of a data set do you need in order to actually drive accurate insights?
Want to go first?
Sure. Give you a break. Really, a few months don't forget we're benchmarking against things that have been widely considered as gospel, so like customs data or association data. So we benchmark versus World Steel Association, we benchmark versus customs. Interestingly enough, on the market intelligence side, we've all grown up assuming World Steel and customs data is, gospel. It's de facto, it's correct. In actuality, it's not. Sometimes you can see that, some countries report a month late in certain circumstances. You can see, so for example, if a vessel docks and discharges a few days before the end of the month, that cargo won't actually get processed and appear in customs data until the following month. So actually our data is leading that. So we see that when we're correlating against benchmark data all the time. But as long as you have 12 months worth of data, you can make a good inference on whether there's accuracy there or not. Actually association data and industry customs data does lead what we do, because we sort of benchmark versus that, and we try and understand flows. Every market, there are certain nuances. For example, apparently, Germany exports a huge amount of stainless scrap, and ferrous scrap, but it doesn't come from sort of Germany's dedicated, ports. It actually goes out through, Holland or Belgium. So you've got to understand the nuances between different markets and actually what you're seeing in the real-time data versus what you're seeing in customs data, for example. So, yeah, don't forget, we're looking at everything on the maritime side every 4 hours, on the sort of the smelting side every day. And so as long as you have about 12 months worth of data, we can sort of get a good degree of accuracy.
Awesome. How about you guys?
Did you know that I wanted to go to grad school before I started this company, and I wanted to do that, literally what you asked?
Yeah. No, I didn't.
Okay,
yeah.
Cool. So predicting how much data goes into a machine learning model to figure out how good it's going to get is a massively unsolved technological problem anywhere and everywhere. And the reason it's so hard to figure out is because you have a ton of different variables you're trying to adjust for at the same time. You're trying to figure out how accurate does this thing need to be, you're trying to figure out how many different settings or configurations of like this one kind of object do I need to actually be able to support? And you're also trying to figure out how fast can I do this, right? One of our biggest bottlenecks is when we analyze a load or a conveyor belt, we have less than a second, because you don't want me to slow down your traffic flow, and you sure as hell don't want me to slow down your conveyor belts. And so we have to also compromise that with, okay, the models can only be so big, because if they get bigger, they get slower, right? So the short answer is, for example, we had a customer a couple of weeks ago that wanted to add lead acid battery support into one of their systems, which is just we hadn't done before. It took us, I think, 350 battery samples to get there. So we basically had someone on the field for like 3 days dropping lead acid batteries at different points of their conveyor belt and making sure we pick it up on the other end, because otherwise I'm causing the problem myself in some ways. And so we try our best to come up with ballparks for customers before we go on site, because it's also respecting the operations time and respecting the operations like commitment, right? Like I see a few folks that sort of, are in the yard, but lots of folks in the yard space, but a few that I've talked to, and all of you know that if I tell you, hey, I need anywhere between 100 and 300 truckloads of material to support this new kind of battery, or like 200 truckloads is a ton, right? And that's the difference between half a day of downtime and like 2 days of downtime, for example. And so we do our best to try and predict what these things are going to look like. We also do our best to learn from previous similar experiences where we've done similar things to give people that like estimated time of arrival almost. But we also communicate to a lot of our customers very transparently that if we don't get to 94%, there is no point. And so it is an iterative process where we will get 300 samples. Maybe we'll get to 80. Maybe we'll get to 85. Maybe we'll get all the way to 94. Sometimes I also have no clue. And that's where, like, to me, expectation setting and making sure we're on the same page with the people we work with is so important, because these systems are based on probability. They're not based on the same thing every single time. And so there is a level of unknown, but typically that level of unknown is matched by the business value we unlock when you make it predictable. And you get there. It's just sometimes, is it a week? Is it a week and a half? We have to work on that together with people to know for sure. Awesome. Do I have other slides? Maybe not. Oh, customization all the way down to the models. We've talked about this. We just build custom models for every customer, and that's why they're able to be so accurate. And in terms of, I guess, what we've learned from deploying AI across, the US at this point is multimodal imaging is extremely powerful. This is not necessarily something we've seen a lot of other people do in both recycling and outside recycling, but combining cameras with other kinds of imaging systems that see through stuff, see around stuff, and frankly bend physics in a way that maybe our eyes cannot bend physics is what lets us actually drive a lot of the business applications we drive, right? So X-ray imaging is such a big part of what we do because it actually lets you see the world in a different way to what cameras let you see the world, which is like human beings see the world, right? And sometimes that's weird to wrap your head around, but the reality is that combining different kinds of imaging systems is actually a really powerful way to drive really legitimate, concrete business value to customers. The second one is customization is absolutely paramount. Like, you have to build systems that respond to different customers' like unique nuances. You have to build systems that sort of fit into the operation, not the other way around. And if you don't do that, no matter how many bells and whistles I put on the AI model, it's not going to drive value anyway, quite frankly. And the third one is the benefit of working across end markets. We started this business thinking that, if we only focused on one end market, we'd get really good at that end market, and then we would just be able to do everything one at a time. Almost counterintuitively, because of the way the models actually work, it's benefited us to sort of be everywhere at the same time and really leverage that data to make everybody's systems better, which has been a cool learning as well. And with that, I'm done talking. So
awesome. Perfect. Well, we're in the discussion portion of the presentation now. So had a couple questions to get things started, and then we'd love some audience participation and stuff. So one of the things that I think came up, like routinely is, in your case, Raghav, like we're trying to drive safer outcomes, know what our material is, recover higher rates of material. Atilla, I'm really curious for you, how has having that data from what mills and what smelters are doing, how has it impacted your customers having conversations with them, when they're in price negotiations and stuff?
Yeah, I mean, there's I won't name names. I mean, on the sort of, I mean, obviously we work a lot with some seaborne suppliers. more than sort of domestic merchants. And you know, some of the scrappies that we work with, it's opened up new markets for them because they didn't know that those routes existed. So they can obviously define very quickly who's active, who's buying, and who's buying in size. So for example, we had a UK supplier that had only been sort of selling into Turkey, that now sort of is selling into Egypt and Morocco, short sea. So it's opened up a whole new avenue for them in terms of being able to sell. On the steel smelting side, I would say that has been very slow to adopt by the physical market. And actually it's really been the funds, derivatives traders, that have really picked up on the value prop, for that, because they understand that actually if you can look on a national basis on the US, for example, and know how the blast furnaces domestically are reacting to the HRC price, then you can then trade the CME contract, and you can take a spec position, right? And so on the LME, for example, if you know what 27 electric arc furnaces are doing every single day, then you can also trade the LME steel scrap futures contract. And likewise, if you know what 300 blast furnaces are doing in China, then you have a pretty damn good approximation for iron ore consumption, demand, and so on. And so you can either trade the Shufi rebar contract, or you can trade the SGX and Dalian iron ore futures contract as well. So, and they've been, you know, very aggressively adopting that product. And I think on the steel mill side, it'll probably take a while longer for physical market to adopt that, because they're trying to understand its value and use for their operations. And it is quite an expensive piece of kit as well. So it's you know, to judge the investment and the ROI on that. But yeah.
Yeah, no, that's super helpful. One of the things too, I'm curious, Julian and Raghav, obviously you guys have a hardware component to, you know, both of your guys' products. For people who, you know, aren't customers of it now, what can they be doing at their facilities from a layout perspective or setup to, you know, set them themselves up well in the event they moved to one of your technologies?
I mean, talking about sorting technologies, this comes always at the end of a process. So to be able to make a good sort, you need to have a good preparation of the material. So this is the key, to have the material in good grain sizes, to get rid of your fines, to get rid of your oversized material, to get rid of everything which is non-metallic, for example. So this is basically the key for before starting looking at the next step. And yeah.
I probably have a slightly more controversial opinion on this, which is the upside to what we do at a AI level is it doesn't matter what the layout of the material is. It doesn't matter how it is oriented. We will come up with an imaging system to see through it and effectively drive the business goal anyway. And so my slightly controversial opinion on site configuration is you shouldn't be doing anything. And if we're not able to directly integrate with what your site does, then that's because our hardware is not good enough and I don't deserve your business and I need to go back, fix it, come back and integrate again. So maybe a slightly different opinion. We definitely have had customer sites where we've looked at and we've gone, you know, there's not enough room on the conveyor. There's not enough room at the scale. But to me, those are signals for I need to make the X-ray smaller or I need to make it more space efficient. That's not a signal for I think the customer needs to change their operation. So my answer is not much. The hardware needs to get better.
Yeah, no, that's super helpful. And it's a testament too to like the models that are being used. You know, AI is very adaptable in that regard and, you know, able to, you know, span, it sounds like, from, you know, waste to, you know, really heavy duty, you know, ferrous metal yards. Yeah, that's awesome. Cool. Well, obviously we've been talking for about an hour now. We have 15 minutes left on the presentation. Wanted to turn it over to the audience. We have some microphones out there. Wanted to see if anyone had any questions for any of the panelists from what you've heard so far. We got one back there.
I'm almost there. So.
All right.
Hi guys, Fernando with SA Recycling. So a quick question. I think learning and hearing about how you guys are kind of creating these data models, right? I think data is important, obviously, as we know. So you guys treat those data models as intellectual property. Is that how you guys are running your business? Because obviously from the middle gentleman here, you know, the data satellites, that satellite imagery and all that becomes sort of a learning curve of that information. And then that information is now your intellectual property. So how does that how does that look for businesses who are trying to acquire AI into their environment if they say they don't work with one of you guys, but they work with somebody who's doing similar things, and then they do miss that battery or they don't have that efficiency that you have being on the ground? I think that's going to be key to a lot of these decisions that are made in the companies because, like what you guys are presenting sounds amazing. There might be another company that's like, oh, we're doing a similar thing, and that data is not the same. That efficiency that you have is not the same. So I think it's more of a comment, like people have to be careful when they're implementing AI to not just be like, oh, you're going to solve all my problems, but maybe not in the way you think that it's presented. So I don't know. It's more of a comment. It's kind of interesting because IP is.
It's a really good one, honestly.
Yeah.
One of the other weird things we do as a business is we don't care about data ownership. Our customers own all their information. We are not in the business of aggregating data. We're not in the business of gatekeeping it from customers. We're in the business of building the best machine learning models that make the most sense of it. And so typically what we do is we ask customers for permission to anonymize and aggregate their data to make their systems better, but they own their data. We own the underlying infrastructure that runs the models and ideally makes them good, but they own their data, which means that should a customer in 3 years decide to, I don't know, like right now, to my knowledge, nobody else really does what we do. But, let's say in 2 years, a bunch of people do what we do because then I'm doing my job, right? And somebody decides to switch, then they should have the complete ability to pull all our old X-ray data, give it to the new vendor and say, train a model. Now, I would advocate that because we partner with the OEM and because we have access to the OEM's data at a level that other people don't, they can take the data, but it won't actually drive the same business gain that it would with us. But that's me being a biased party. So that's just me being me. But I think the point of sites needing to own their own data and the point of, not allowing really exhaustive like vendor agreements to sort of change who owns your data is extremely critical. And I think especially as you start looking at like producer responsibility or you start looking at, net zero tracking across the board, people are going to start asking for like source of proof for these things, which is going to be the data off our X-rays. So people have to own it because otherwise they're not going to be able to monetize it, quite frankly.
I'd probably just add on, you're right about the IP and so on. Our sort of stuff is more sort of trading, supporting trading decisions. It's always going to come down to the man in the box at the end of the day, or the lady in the box. But I think you also touched on in your presentation, being there to be able to provide support as well, interpret the information with the client and how to come to that desired outcome or that conclusion, what the data is telling us. Because on the scrap supply side, a lot of companies don't have their own research departments or analysts or, majority of people walking the yards, even, companies doing 500,000 million tons a year exports out of UK, Northern Europe, they just don't have the time. So they sort of outsource that to us and we sit down with them once a month and walk them through it. And, this is our view based on data, but, you're welcome to interpret it how you want to interpret it or how you think you should interpret it. So it's case by case. And, that's why, it's not a one size fits all. It's the same data, but it has different applications to different, sort of our clients. So some clients know exactly what's happening in deep sea market. They don't need that information, but they want to know what's going on upstream. Who are their short sea suppliers flying into? Why am I not getting that cargo? Why is it going to someone else? And agents in Turkey, they're selling cargoes on behalf of a particular supplier. Why am I not getting that business short sea into Morocco, for example? So there are so many ways you can skin a cat. But yeah, just being there to be able to provide support and interpretation of that. So you guys can do what you need to do.
Yeah, definitely. One comment on that, the data sharing model. One thing, seeing a few different industries and like with our, material identification app that we built, it's one of those things where, you opt into it and we make it very clear, like, hey, your data is also going to be used to train this model. Obviously, it's not being shared with anyone else. And it's sort of, hey, if you're going to use this service, you're opting into your data being a part of the training model. And ultimately, we view it as the thing as, rising tides help all boats. Like at the end of the day, that allows us to sharpen the technology, which will, hopefully be better for your business at the end of the day. Any other questions? And oh yeah, back there. Feel free to just say it, or if you just want to talk loudly.
The single biggest driver to better model performance is more data. And that's why the longer we have been at customer sites, you will see the accuracy continue to rise even when we don't do anything. And so truly it comes down to a trade-off between how much time is the site willing to give us to do stuff that frankly is not a part of their day-to-day operation, and they're doing at a cost to us or a cost to themselves to let us get these systems to work well. And where is that cutoff point where we can go, okay, cool, this is good enough, we're going to use it in the field, and then it is still going to get better. Like, so 93.5, for example, which is the number on all my slides, is what we start at. It's like our threshold to commission, because if it's lower than that, you're missing too many batteries for this to be worth anything, frankly. But that's not what we sit at forever. Like, these numbers will be at 96s, 97s, sometimes they go higher. When you're at 98% accuracy, you miss two things and it goes down. So it's a weird number to report. But it truly just comes down to how much data we can collect. And that comes down to how we can create situations with our customer sites to collect that data. We go in, there's one person in the audience that works with us. We go into his site on weekends, because it's the most efficient time to actually collect this information, because ideally we're not interrupting them. And so to me, the bottleneck is just data. Like, we're solving problems that are so niche that nobody has these data sets. And why would anybody have x-rays of full loads of ferrous metal going into yards? Like we're the only people nuts enough to put these cargo scanners into the first place, frankly. And so when you're dealing with problems with no data to begin with, that's your greatest lever. It's just collecting more of it over time. And then the faster you do that, the better the models get.
So first of all, Attila, was not expecting Nucor's stuff to be popping up. I was, oh my God. Clearly some of my coworkers know about this, but this was new to me. So that was pretty cool.
Your client's ready.
But my question, you sparked my interest when you said you could determine the chemistry of batteries coming in on loads. Obviously I got like a million questions about, setting up an X-ray on a scale and the feasibility of all of that. But is that something you can do for storage of batteries as well? Because like, as we're trying to sort through batteries, ship them to different people, that would be extremely helpful, especially when labeling is poor and it's hard to differentiate. Is that something that you can do in a storage facility?
We do real-time battery triage and sorting for customers in the battery recycling business. So if you give me a conveyor and the opportunity to put an X-ray on top of that conveyor, I could tell you what the chemistries of the batteries are as you put them on the conveyor. Yes. It's again, it goes back to the mechanical aspect, like where is it going to go? How's it going to be staged? That's where the conversation really gets interesting.
So then for infrared thermal runaway, is that something you've looked at being able to predict, or is that too far out right now?
So we've looked at incorporating infrared/FLIR systems. My current view on it is actually that the fire suppression market does a very good job of servicing those cameras already. I think one of the important aspects there is a lot of the fire suppression companies also have like the foam gun that you can shoot foam with, right?
Right.
And a lot of, I think the value they bring is that last second human check before you shoot the foam gun. Because to me, autonomously shooting a foam gun is sort of terrifying, full disclosure.
Yeah.
So I think it's something we've explored, but we've honestly explored it more in the context of, can we work with the suppression companies themselves to make their internal quality control better, so they can then, frankly, charge better rates to their customers, who are also our customers. But I think it's where in that value chain we fit in, and it's not always actually directly to the customer. Sometimes it's helping the vendors get better, and we sort of do it across the board.
That makes a lot of sense. Thank you.
Of course.
Awesome. We have time for one more question if anyone has one. You don't need to come up to the mic if you just want to yell it out.
Yeah, well, I guess I will. I speak as CEO of sort that got it, but I was also one of co-inventor of portable XRF technology and CEO of Nikon, Gaku, and Ramen, X-ray imaging, backscatter imaging, CT monitor, lives where in the world do you think can non-destructively identified as batteries on a bigger one? No way.
Well,
Absolutely no way.
when you say every kind, what do you mean?
I mean, in real time, in 1 second, cannot be done. Simply cannot be done. With XRF, your limitation is to see a millimeter into the material. It's all the surface of the battery. Lives 100 microns in the battery. They're teaching today.
Not to cut you off. I just want to get to what's the question?
The question, how does AI finally help them? You gotta have some kind of sensor technology that can identify it. I'm sorry, I forget your second on the,
Julian, yeah.
apologies.
Yeah. No.
Everything you said makes sense. Exactly what you said makes sense. Pre-sort everything. You homogenize as much as possible, and then it works. But how can you do it without all of that work initially?
This feels like a question to me.
I think so. Attila, do you care to comment?
So I'll give you two pieces of context. The first one is we use retrofitted XRT systems. They're not exactly XRT scanners. They're XRT scanners that we've co-developed with a large X-ray OEM. So it's not off-the-shelf XRT. It's a weird version of XRT is what I describe it as. Secondly, we've rewritten all the actual underlying processing software that takes data off the detector boards and does fun things to them. And the third part is, honestly, I'd love to show you videos or invite you to a site, but I don't know how else I would show you. I'm sorry? We're not doing just XRT. The whole appeal is multimodal. So we have XRT, we have other sensors. We sometimes pair XRT with cameras. We sometimes do XRT, camera, and IR all in one tunnel. So it really depends on the application. But that's where the value of
figure out, even with XRT, like how you're ever able to see like the battery in a.
I'd love to show you, honestly. Yeah. I don't have a better answer.
Something running, hundreds of kilograms per meter on it.
You should come check out a demo, honestly.
Okay, I just want to say I've seen your system. I've seen it work. It works.
Thank you, Susan. Appreciate it.
All right. All right. Well, with that, sounds like a good opportunity to hit the convention hall and check out some of the technology out there. But thank you all for coming and attending. Have a great rest of the show. Thank you very much.
Thank you.